Hello everyone, welcome to the next lecture on the calculus. Today I will explain you how you can find the average value. Myself Dr. Harish Garg. You can follow my YouTube channel where you can find the playlist of the Mathematics 1 calculus. And we have discussed a previous lecture how you can find the area and the volume of the region. Now based on these two lectures, I can say how you can find the average value. Let me quickly recall you how you can find the area. Area is nothing but the double integration of dx into dy, or you can find the double integration of dx into dy. Fine. For more detail, you can watch about my this lecture. I hope you can subscribe my YouTube channel so that when I uploaded my next video, you will get the notifications. Now, in this lecture, we will see how you can find the average value of the function. I am very sure that you had heard about the term average value, which is defined like fx by f. Fine. Now, if I correlate this into the xy plane, and this is say my function fx, the corresponding value is my a, this value is my b, and this is my f of x comma y. And then what is the meaning of this summation of the f? You can discretize this domain or the strip into the vertical, fine, and then the denominator will represents about my area of this region. Fine. This is the sum of the, what is the sum of this f? That is my area from the A to B. I call this is my region. So how you can find the area? We all know it's a double integration dy into dx. Now how you can find this summation of the fx? That means you can multiply this f x. Now in this xy plane, you can say into the dx of dy. That is a double integration. And what is the meaning of that? This is nothing but my volume. Fine. So what you can say about that? The average value of the function is my volume of the function over the region divided by area of the region. Fine. So how you can find the volume? For more detail, as I told you, watch this area and the volume lecture. So if f is my integrable function, then we can define the average value is the integral of the region divided by the area. Mathematically, we can say 1 over area into what is the representation of this part? This part is my nothing but volume. So therefore, you can say the average value is volume divided by area. So I will explain you with the help of the numerical examples. Find the average value of the function over the rectangle, this case. So your target is to find this number. First of all, whatever the region is given to you, you can draw it diagram. So x is equal to 0, x is equal to pi, y is equal to 0, and y is equal to 1. So my shaded area will be this one. Fine. And this is my basically region R. Then your first target is to find the area of the region. How you can find the area of the region? So as we know, it's a double integration of dy into dx. Can you find the limits of the y? Take the vertical step, the value of the y at this point 0, the value of the y at this point 1. Minimum value of the x is 0, max value of the x is my pi. Now if you solve this integration, you will get the answer as pi. So therefore the area is my pi. Otherwise, you can also find the area in the other way. If you look about the diagram, what is this diagram represents? That diagram is my rectangle, and once it's a rectangle, how you can find the area? That is, if I say this is O, A, B and C, so that will be length into breadth. What is the value of the OA? That is a pi minus 0. What is the length of the AB? 1 minus 0, because this number is my 0, this number is pi, so the length is pi minus 0, this number is my 1, this number is 0. So again you can see the answer is pi. So that's on your choice. If you have say for example square, circle, rectangle, then you all knows how you can find the area. You can write it directly. Otherwise, find the area by using double integration. So therefore, now I can find this double integration of f. F is my x into cos xy of dy dx. Fine. Or you can also use x into cos xy dx into dy, but make sure if you're using the dx firstly, then you have to use as a product rule for the integration, while if you are using the dy firstly, then this x is my constant. So the better is that I can use this component. So take the vertical step, the value of the y is my 0, value of y is my 1, this is 0, this is pi. Fine. So now can you integrate them? So that's the integration is very easy because I keeping y. So that means x is my constant. I can take x is outside. Integration of the cos is sine xy divided by x from 0 to 1. So can you substitute this upper limit and the lower limit? This is x sine x divided by x. Sine 0 is my 0. So x will be cancelled out. Integration of the sine is my minus cos x from 0 to pi. So it will be my minus 1 and it is my cos 0 is 1. So 1 plus 1, 2 is the integration. Fine. Now, therefore, what is the answer of the average value? So average value is 2 divided by area. Area is my pi is the required answer. This is the first example. We will cover that 8 to 9 example more in this lecture. Don't forget to like and comment on this video as well. You can share this video with your friends also. Okay, look at that. Firstly, whatever the reason is given to you, you can draw it diagram. X is 0, x is equal to pi, y is equal to 0, and y is equal to pi. Fine. So your shaded portion is my this part, and this is my region R. Can you find the area of this region? Area of this region. Clearly say this represent my square. Fine. So what is the area of this case? OABC. OA into AB again. So that is a pi into pi. So that is my pi square. So the area of the curve is my pi square. So therefore, I can find the average value is 1 over pi square, double integration of sine x plus y dy into dx. So take the vertical step. What is the value of the y is my 0. Value at the upper point is my pi, and this is my 0 to pi. Fine. Now can you solve this integration? It's a 1 over pi square. Integration with respect to y. So keeping x is my constant. So minus cos x plus y from 0 to pi of dx. Now you can substitute the upper limit. It's a x plus pi and cos of 0 is my this case. Can you find the value of the cos pi plus x? It lies in the third quadrant. So it's a negative. 180 by 90 is an even number. So it's my cos of x. So it's a minus cos x, minus minus plus cos x, and cos x is my twice of cos x. I can take 2 over pi common. Then integration of the cos is my sine x from 0 to pi. So that will be 2 over pi square. Sine pi is 0, cosine 0 is 0. So the answer is 0 is the right answer of this problem. I hope you can like and comment on this video as well. Find the average height of this region. Again, your target is to firstly draw this curve. So x is equal to 0, x is equal to 2, y is equal to 0, y is equal to 2. So my region is R is my this curve. Can you find the area? Because your target is to find the average, so you need to find the volume and the area. Can you find this area? O, A, B and C. So clearly say this is my square. Fine. So the area will be my length 2 and side square. So this is my 4. So area is my 4. Therefore, what is the average value? Average value is 1 over area, double integration of the f. F is my x square plus y square into dy dx. Now take the step. The value of the y at this point is 0. Find the value at this point is my 2 and the lower and upper limit of this. Make sure z is the function of the x and y. Now can you integrate them? 1 over 4 integration with respect to y, keeping x is my constant, so x square y plus y cube over 3 from 0 to 2. Now you can substitute the upper limits, you will get as 2x square 8 over 3. Now can you integrate them? It will be 2x cube over 3 plus 8x over 3. Now you can solve this part. You can substitute the upper limit. It is my 16 over 3 plus 16 over 3 minus 0 minus 0. So that will be 32 over 4 into 3. That is 8 over 3 is my right answer of this problem. Don't forget to like my this video. Find the average value of the functions bounded by the curve and the line. So firstly, y is equal to x. This is the line of the y is equal to x. Fine. Then, and the curve y is equal to x square. Fine. Y is equal to x square. Now, find the area. What is the shaded portion bounded above by the line? Remember, bounded, this is a line which is bounded above by the line. So this is bounded above by the line. This is a bounded curve and it is bounded below the curve of the parabola. So this is the bounded below because this is the line of the below. So my shaded portion is, this is my shaded portion. Fine. Now clearly say this point of intersection is my 1 comma 1. This point of intersection is my 0 comma 0. How you can find the area of this curve? So clearly say this is not my square. Fine. This is not my rectangle. So you are unable to know the formula for this curve. So then we can find the area is dy into dx, or you can find the area as dx into dy. Fine. Now if I find the area as dy into dx, can you find the vertical strip? What is the value of the y at this point? X square. The value of the y at this point? X. The minimum value is my 0, maximum value is my 1 at this point. Now you can solve this integration. It is keeping y, so that is y from x square to x of dx. So this integration will be x minus x square. So can you solve this integration? It is my x square over 2 minus x cube over 3 from 0 to 1. So what is the answer of this? 1 over 2 minus 1 over 3. 1 over 6 is my area of the region. So therefore the average value will be 1 over area, double integration f. F is my x minus y into dy dx. So 1 over 6 I can written as a 6 times. Fine. And the limits are my. So can you solve this integration again? Now integration with respect to y. So x is my constant. It is y square over 2 from x square to x. Fine. Now you can substitute the upper limit. So it will be my x square and minus x square over 2. So that will be my x square over 2. If you substitute lower limit is x cube plus x4 over 2 into dx. Now you can solve this integration. What is the integration of this part? It's x cube over 6, x4 over 4, x5 over 10. Now that's the final answer. 1 over 6, 1 over 4, 1 over 10, minus 0, minus 0, minus 0. Now you can take the LCM and you will get the right answer as 1 over 10. So look at this next example. Make sure students, whenever you have finding the limits or the volume, watch out this lecture of the volume and the area of the curve. Look at this next one. Find the average value. Again, firstly draw the curve. X is equal to ln2. So this is the value of the ln2. This is the value of the twice of ln2. This is the twice of ln2. This is my ln of 2. Similarly, y is my ln2. This is y is equal to ln2 and this value is my y is equal to twice of ln2. So my curve shaded area is my this part. Fine. Then your required target is to find the area of this region. So how you can find the area of this region? Clearly say this is my sphere. So the area is AB into BC. So what is the value of the AB? So AB, that is a twice ln2 minus ln2. What is the BC? Again twice ln2 minus ln2. So that this value will be ln2. This value is also ln2. So the answer is ln of 2 square. So this is the value of this area. Now you can find the volume, or the average value will be 1 over area, double integration of this part. How you can solve this integration? Again, it's a very simple, because you have to integrate this with respect to y. So keeping x is my constant, so 1 over x is outside, integration of the 1 over y is my ln of y. Fine. This is the integration. Now you can substitute the upper limits and the lower limits. You will get this expression. Then I can use either ln x minus ln y, which is equal to ln of x over y. So what is this expression? This is 1 over ln of 2 square, which is ln of 2 twice ln2, 1 over x. If I use x over y, this expression becomes ln of 2. Fine. Now I can cancel this ln x2 by the outside value. Your expression becomes only 1 over x. And what is the integration of the 1 over x? Again, it is my ln x. Again, I can substitute the upper limits and the lower limit, and again I can use the ln x minus ln y, which is equal to ln of x over y. So this expression becomes ln of 2. So that will be cancelled out. It is my 1 is the right answer. I hope you can like and comment on this video as well. Find the average value of this over the rectangle. So firstly find this rectangle. This is x equal to pi, y is equal to 0, y is equal to pi over 2. This is my region R. How you can find this area? Again it's a rectangle, so I can easily find the length is AB into BC. What is the value of the AB? Is a pi minus 0. The value of the BC is pi by 2 minus 0. The area is pi square over 2. Once you know the area, I can substitute this value. It's 1 over pi square by 2. That's a 2 upon pi square, and the function is sine of this value. The limits are 0 to pi. Now can you solve this integration? Firstly integrate with respect to y. So minus x plus y from 0 to pi over 2. I can substitute the upper limit as a y, so it's a x plus pi by 2 and 2. Can you find the value of these? Pi over 2 plus x, it lies in the second quadrant, is a negative, and the sine of x. So this value is my minus sine of x, so minus minus plus is a sine. Can you find the integration of sine x plus cos x? It is my minus cos x plus sine x. Fine. From 0 to pi. Now you can substitute the value 1 over pi square. Cos of pi is my minus 1. Sine of pi is my 0. Minus cos of 0 is my 1. And sine of 0 is my 0. So 1 plus 1 twice. It is 4 over pi square is the right answer of this problem. Look at this another one. Which do you think will be larger? The average value of the f over the square, or the average value of the f over the quarter circle? That's very simple again. Why? Because firstly you can solve this problem over the square, and then we can solve over the quarter circle and we can compare them. So firstly I can solve over the square. I can draw the feasible region. Clearly say the area is my 1 into 1. Then the average value will be 1 over area double integration x into y dy into dx. Take the vertical step 0 to 1, 0 to 1. Can you solve this integration? Integration with respect to y, so keeping x is my constant, y square by 2 from 0 to 1. So that part will be 1 to x. It is x over 2 into dx. Can you solve this integration again? So it is my x square over 4 from 0 to 1. So the answer is 1 over 4. Now we can do this part for the quadrate circle. It's a circle whose the radius is my 1 and it lies in the first quadrant. So that means the area shaded portion is only my this part. Fine. Then can you find the area of this quadrant? So area is 1 over 4 into pi r square. What is the radius? You can see the radius is my 1. So the answer is pi over 4 is my area. So therefore average value is my 1 over area into this one. Can you find the limits of this? What is the value of the y at this point? 0. The value of the y at this point is 1 minus x square. And the value of this x is my 0 to 1. Now you can integrate them keeping x as my constant. So it's a y square over 2. I can substitute the upper limit. You will get this expression. I can cancel out. It's a twice over pi. Then this is my x minus x cube. What is the integration of this? X square over 2 and x4 over 4 from 0 to 1. Now you can substitute the limits and you will get the answer as 1 over 2 pi. Fine, which is approximately is 0.159, while this number is my point of 25. Now clearly say 0.25 is larger than of the circle, therefore the average value of the square is my larger. So you can see that it's a very simple way you can find the average area, provided you have watched about my area and the volume lecture deeply. We will see the next lecture on the moments and the center of mass very soon. We will, till then you can like, share and comment on this video, and don't forget to subscribe my YouTube channel. Thanks for the watching and thanks for the support. Happy learning always. Best wishes.